So hello, welcome back to live session again. Yeah, so let's look now at a different thing today, this evening. So we're actually looking at apoptosis in physiology. They make both the mechanism, both the extrinsic and the intrinsic part. Okay, yeah, and my voice is sounding a bit of hoarse. So if you get to maybe you are not able to hear me, I'm sure but you're able to hear me. Yeah, I'll be fully taking care of you guys. So yeah, let's now just dive direct into what apoptosis is. So basically apoptosis, I can say in simple terms, this is for you just to understand. Apoptosis, I can say it's just something about society, the cell committing society. Okay, then there's also what you call necrosis, which is also called murder. Okay, so actually apoptosis is a pathway of cell death that is induced by tertiary regulated intracellular program, which cells they are destined to die or to activate the enzyme though, and these enzymes is what we call caspases. These they will degrade the cell's own nuclear DNA and cytoplasmic proteins. Okay, so the most important pointers that you need to know is so one, the cell is going to be phagocytosed, and two, there is no leakage in outside, and three, there is no inflammation. So the pointers that you need to know. So maybe for the sake of those who are joining late, let me write the definition for you. But the simplest definition that you can know about apoptosis is actually the programmed cell death. Okay. Yeah. So if you need the drawing document, it will be sent again the group. Yeah. Actually, apoptosis you have two mechanisms, but this is for the cell to commit suicide, for the cell to die. Actually to receive a signal, and the signal can be coming out. The signal can be out of the cell or intracellular or inside the cell. That's why we are going to segment this into two mechanisms. So like if you have in this cell and that has content inside, okay, so the signal can be coming outside of the cell. The signal can be outside of the cell, and when the signal comes, they will activate the enzyme, what we call caspases enzyme, the caspases. Okay, the caspases, and then from there, this is just an illustration, but the proper mechanism will be shown. From there, the cell will form apoptotic bodies. So when the apoptotic bodies are being formed, apoptotic bodies. When these apoptotic bodies are being formed, they are going to be phagositosed or engulfed by the phagocytes. Then there will be phagocytosis, and the cell will be eliminated. Since it's not functioning, the cell is already dead. So actually, we have two mechanisms of apoptosis. We have a mechanism of apoptosis. We have two mechanisms of apoptosis. So one, we have extrinsic pathway. So the extrinsic pathway, okay, and the extrinsic pathway has two parts. It has the initiation phase and the execution phase. Also, the intrinsic pathway, it also has the initiation phase and the execution phase. But the only difference between these two pathways, it is the initiation phase and the initiation phase, but it has the same execution phase. Okay, so this has initiation phase and the execution phase. Even the intrinsic pathway, it has the initiation and the execution phase. Okay, Yeah, so you guys, yeah, I'm sure you're about to follow what I'm saying. Okay. So now let's start with the extrinsic key, the one which the signal is coming outside. So you have to know the extrinsic pathway. So we start with the extrinsic pathway. Okay. So this extrinsic pathway, we're starting with the initiation phase. So this one is initiated through the specific receptors, what you are calling them, the death receptors. It's going to be initiated through the specific receptors that we are calling them the death receptors. And this one is the trigger. The trigger is going to be caused by the external signals binding to death receptors on the cell membrane. Okay? So it's going to be caused by external signals binding to death receptors on the cell membrane. So the key receptors that you need to know about the extrinsic pointers. The key receptors. The key receptors, one, we have the fuzz receptor, which is also called the CD95. Yeah, we have the fuzz receptor, also called the CD95. Another receptor that you can talk about, we have the tumor necrosis receptor 1. We have also abbreviated as TNF receptor 1, like this. Tumor necrosis factor receptor. Okay. Also, you can also have the trail receptor. The trail receptor. You can also have the trail receptor. You can also have the trail receptor, the TNF related apoptosis inducing ligand receptor. It is also called the TNF related apoptosis inducing ligand receptor. So here is the mechanism now. You need to follow. One, let me use the diagram so that you're able to follow the things. So here let's have a cell with many receptors actually. So it has many receptors. This has many receptors. Okay. I want you to get this concept from here. Okay, and there's a nucleus there, and there's the entity in the nucleus there. Okay. So now, since we are saying for the extrinsic pathway, the signal is coming from outside the cell. So the ligand so here is the ligand, which is the signal. So the ligand can be the CD95, or which is also called the fuzz receptor. So this one, fuzz receptor, is going to bind to this receptor. When this fuzz receptor binds to this receptor, the death receptors, also called the fuzz CD95 receptor. So when the ligand binds to the receptor, the multiple receptors, they will come together, and the receptors will form the domain which is called the death domain. So when this one binds here, what you're going to happen is this. The same cell. So we're going to have receptors coming together like this, forming the death domain receptor, forming the FADD. To form the FADD, which is fuzz associated death domain. It is called fuzz associated death domain. Okay, fuzz associated death domain. Okay. Alright, I hope you guys are following. If you are following, just type FADD in the comment section. Yes, I see that you guys are actually following. Okay. Should I repeat the pointers? Should I repeat the pointers? So when the receptors come together, so that is the adapter proteins, the FADD, phase associated death domain, receptor death domain. So then there will be a formation of a disc. So there will be a formation of a disc. From there will be a formation of a disc. So this disc is called disc. This is an abbreviation, so it is called the death-inducing signaling complex. It is called the death-inducing signaling complex. It's a death-inducing signaling complex. Okay, the death domain inducing signaling complex. If you are following, you guys just type disc in the comment section. Just type up disc in the comment section. I'll run through the pointers again for the extrinsic pathway of the apoptosis. Okay, as a summary, so this, the FADD, which I told you to say it's a phase associated death domain. It is the one which it will recruit the procaspase 8 or the procaspase 10, the 8 and 10 in extrinsic pathway. So this disc, how is the disc going to be formed? So the disc is the combination of the receptor, the FADD, and the procaspase 8 and 10. So this complex, the death-inducing signaling complex, is the combination of the receptor plus the FADD plus the caspases, which is their enzymes, procaspase 8. This will form what is called disc, which is death-inducing signaling complex. From there will be now activation of the initiator caspase. So since this is an initiation phase, I said in the introduction to say both the extrinsic and the intrinsic, they have the same exclusion but the different initiation phases. That's the thing. So from here we're going to have activation of initiator caspase. So the procaspase 8 molecules, they will cleave each other to form the active. Okay, from the diagram that I showed you to say, when the ligand binds, the receptors come together, okay, and form the FADD. So when the FADD forms, so there is a ligand which initially binded here, so that these receptors come together. So when they come together, they form the phase associated death domain. So the combination of the ligand, the receptor, and this is the one which forming the disc. Okay, so from the disc there will be activation of the caspases. The caspase, since it's a procaspase 8 to be activated, 8 and 10. In extrinsic, it's 8 and 10 to be activated into its active form, which is caspase 8. Caspase 8, not a pro, but just caspase 8 and 10 into the active form. So this is not in the active form, but this is the active form. So this is the initiation phase of the but the mechanism is not yet done. There is an exclusion part which I'm going to match them with the intrinsic pathway so that it makes sense. Okay, from here to be the exclusion phase, which will to activate the other caspases like 3, 6, and 7, and will form cell dismantling. So that one I'll talk about it. On the exclusion phase. Okay, so for now let me talk about the initiation phase of the the intrinsic pathway. Rather the intrinsic pathway. So if you're following, just type in the comment section. Good. I've seen you guys have you have joined. Also welcome to live session, Dr. Lombe. So you are welcome, you are welcome, you are welcome. Feel free to ask questions. Yeah, so let's start with the intrinsic again, the initiation phase of the intrinsic pathway. So actually the intrinsic pathway. Okay, so for the intrinsic, from the word intrinsic, you can even think of intrinsic is meaning inside, so meaning the signal is coming from the inside. Now what is causing the signal, what is triggering the signal? So this is caused by internal stress signals, such as maybe the DNA damage in the nucleus. Maybe it's going to be damaged maybe by radiations, the toxins, or they can talk about the growth factor deprivation, or the oxidative stress, the accumulation of misfolded proteins, the hypoxia. All these are the one which will trigger a signal from the intrinsic pathway of the apoptosis. Okay, so the trigger here, the initiation phase of intrinsic pathway. Okay, or in bracket you can write mitochondria, so that to be able to help you to recall the information. So what's the trigger here? The trigger, so the trigger here, pointer, the trigger here, it can be the DNA damage. Secondary, I said also DNA damage, also the growth factor deprivation, or it can just be the stress of the they say oxidative stress. All this. Okay, so talk about the accumulation of maybe the proteins are misfolded, the hypoxia. Yeah, okay, let me just draw something so that you appreciate from the diagram as I explain the intrinsic pathway. Okay, let me just draw something so that you guys appreciate what I'm going to talk about. Okay, yeah, we don't draw like an artist, this is just for you to understand. Yeah, I hope you get sense from it. Okay, something like that. Then here we have a nucleus with the entities there. So there we have the DNA. Okay, the deoxyribonucleic acid. Yeah, so the signal will be coming from here, which is the signal DNA damage. Signal can be the DNA damage. Okay, DNA damage in the nucleus. Okay, so here we have the mitochondria and the red thing you are seeing here is the cytochrome C. It's a protein. So the red thing here is the cytochrome C. It's a protein.